Hello everyone, welcome to your channel Sukh EduWorld. In this video, we will cover next 10 questions. Okay, we will solve next 10 questions of this question paper from 31st to 40, and I had already provided you solutions of first 30 questions, and I had uploaded 3 videos. You can watch that videos on this channel, and let's start. So in the 31st, they are saying match the following source of electrode polarization, and where they arise from. So sources, they are giving ohmic, kinetic activation, transport concentration, crystallization, and accordingly they are giving you uh, 4 options, okay, from where there arises. So you have to just meet with correct option. Okay, so in this case, like this is crystallization, and obviously it arises from crystal growth, so there is C option for S. Okay, so which is only in second option. Similarly, you can also check other kinetic or activation. Okay, so this is source of electrode polarization, kinetic or activation, and it arises obviously from reactions. Okay, so they are giving you electrode reactions, so there is D option for Q, which is also in B. Okay, B option they are providing you. Next, ohmic, okay, or a transport concentration, that is related to reactant concentration, so which is in A option. Okay, so that is A for R. So this, and similarly ohmic, you have to meet it with the ionic migration. So ultimately B option is correct answer for this question. In the next question, which of the following statements about fluorines is incorrect? Okay, so you have to mention incorrect statement as your correct answer. Okay, according to 4 options. So first option is structure of C60 has 20 hexagonal faces and C70 has 25 hexagonal faces. So this statement is correct actually. When you will read about C60 and C70 fluorines, you will see uh, this statement is correct. Okay, so second is the electron at each carbon is delocalized. Electron at each carbon is delocalized into the system of molecular orbitals that give the whole molecule aromatic character. So this statement is also correct. Okay, third is C60 can undergo a 6 electron reduction until the T1U level, lowest unoccupied molecular orbital is completely filled. So this statement is also correct. So fourth statement is the entire set of carbon atoms are equivalent, sp2 hybridized, and have a strong plus I effect. So this statement is incorrect and is your correct answer. Okay, out of 4 options. So what happened here, if we talk about fourth option, so they are providing the entire set of carbon atoms are equivalent. Okay, and each carbon is sp2 hybridized and have a strong plus I effect. So while all carbon atoms in fluorine are equivalent, okay, that is correct, sp2 hybridized, that is also correct, but they don't have plus I effect as it mentioned in last part. Okay, strong plus I effect. So however, all carbon atoms are equivalent sp2 hybridized, that is correct, but all have no plus I effect actually. The electronic environment varies slightly depending on the position of each carbon atom within the fluorine structure. So all carbons have no plus I effect. So it depends on their position, where they are lying in fluorine structure. So that's why fourth statement is incorrect and is your correct answer. Clear? So fourth option is your correct answer. In the next question, match the hazards waste with their source. So these are the materials, okay, that are hazard and their sources. So fourth option is correct. Okay, dioxins, actually for dioxins, their source is pulp and paper plant. Clear? And infectious Waste is generated basically, its source is hospitals and research lab. Clear? And for dioxins, pulp and paper plant, and nerve gas is for generated from old military installations. Clear? And pesticides released from household products. So fourth option is your correct answer. In the next question, which enzyme is used for the hydrolysis of urea? So correct answer is urease. Urease enzyme is used for the hydrolysis of urea, okay, and converted urea into carbon dioxide and ammonia. So after hydrolysis of urea, so hydrolysis occurs here and urease enzyme works here and converted it into carbon dioxide plus ammonia. Clear? So fourth option is your correct answer. In the next question, how can the energy of molecular orbitals that form the band can be found? That form the band, not band, that form the bond be found. Okay, so correct option is Huckel molecular approximation. So in Huckel molecular orbital approximation, we are talking about molecular orbitals. So Huckel approximation is a method used to determine energy of molecular orbitals. Okay, used to get information about energies of molecular orbitals in conjugated systems. In conjugated systems. Which conjugated systems? Like, for example, benzene, cyclopropynyl, okay, cyclopropynyl system, pyridine, these type of conjugated systems. Clear? And in that case, energies, to get information about energies of molecular orbitals in conjugated system, Huckel approximation is used. Okay, so fourth option is correct answer. In the next case, next question, they are providing you 4 orders and you have to uh, tick one option as a correct answer. For correct order of d orbital splitting in square planar complex geometry. Clear? So correct answer is fourth. Okay, so in this case, dx square minus y square, so this orbital, okay, so this orbital experiences most repulsion clearly because it is directly aligned with the ligands in square planar geometry, so it has high energy. Okay, so reason is it is directly aligned with the ligands. Clear? And if you talk about dyz and dxz, which has almost equal energy and has least repulsion actually, and are nearly degenerate and lies in plane perpendicular to ligands, lies in plane perpendicular to ligands, and these dx square minus y square has a high energy because it align directly towards the ligand, but it is perpendicular to ligand, that's why feels less repulsion and has less energy. If we talk about other two orbitals, dz square and dxy, and you know you are talking about square planar complexes, and for square planar complexes you will see ligands along x and y direction, and obviously then you will see greater repulsion along x and y as compared to dz square because there is no ligand along dz square. So dxy has higher energy as compared to dz square. So fourth option is your correct answer in this question. In the next question, at which temperature does water become dense? Okay, so then water become dense at 4 degrees Celsius actually. So at this temperature molecules are most closely packed, so making water denser than at higher lower temperature. Clear? So 4 degrees Celsius is correct answer. In the next question, find lowering of vapor pressure caused by addition of 100 gram of sucrose. So 100 gram of sucrose, its molecular mass is 342, is added into 1000 gram of water and vapor pressure of pure water which is 23 mm mercury at 25 degrees Celsius. Okay, so ultimately you have to find lowering of vapor pressure, so which is change in pressure. Clear? So change in pressure, so for that what you will do, it means that change in pressure will happen. First you have to subtract pressure of solution when you will add 100 gram of sucrose into water, so you will get solution and its vapor pressure you have to subtract it from pressure of pure water. Clear? And in this, you know, pressure of pure vapor is already, pure water is already given, which is 23.8. So you have to find pressure of solution. Clear? Now, so this is your first equation. So you to find pressure of solution, which is equal to mole fraction of pure component. Pure component is your water. Okay, multiply pressure. Okay, pressure of pure component, which is pressure of pure water. Clear? Now pressure of pure water is given, which is 23.8. Now you have to find, this is your second equation. Clear? You have to find mole fraction of water. What you will do to find mole fraction of water, that is equal to moles of water, right, divided by total moles. Clear? And total moles you will find, first of all in this case you have to find moles of water. So moles of water, how to find? To find moles, that is equal to mass of water divided by molar mass of water. So mass of water is already given in question, that is 1000 gram. Clear? And molar mass of water you can calculate, that is equal to 18, and after solving, when you will solve it, you will get 55.56 mole. Okay, so this is mole of water, that is 55.56. So in the numerator you have value 55.56. Clear? Now you have to find total mole. Total moles meaning mole of water plus mole of sucrose, right, in the denominator. You know the mole of water, which is 55.56, but to find mole of sucrose, again you have to find moles of sucrose. You have to divide its mass by molar mass. Clear? Its molar mass is given, that is 342 and mass is 100. So you will divide 100 by 342 and this is molar mass, moles of sucrose. Clear? When you will solve it, you will get 0.292 moles. So this is the number of moles of sucrose. Now you will simply, I will erase it. Okay, I will erase it because of less space. So in the denominator you will add total number of moles, moles of water plus moles of sucrose. Clear? So moles of water is 55.56, and moles of sucrose you calculated, that is 0.292. Clear? So when you will add it and divide it by 55.56, you will get 0.995. Clear? So this is mole fraction of water. So fill this value here. Mole fraction of water 0.995. So when you will multiply it, you will get answer 23.6 mm of mercury. Clear? Now this is pressure of your solution, that its value you found 23.68. And now this is pressure of solution, fill this value 23.68 here, and when you will subtract it 23.68 by subtracting, you will get value, that is 0.12 mm of mercury. So which is your first option? So A option is your correct answer. Clear? So this numerical is very easy. A option is your correct answer. In the next question, which of the statements is correct? Okay, so your first option is, you have to mention correct. First is labile protons are generally more shielded. Clear? And this statement is incorrect. Actually, labile protons, such as those involved in hydrogen bonding, are generally more de-shielded, not shielded, and they are mentioning it shielded. Okay, so labile protons are generally more de-shielded. So first statement is incorrect. Second is, an alpha beta unsaturated ketone beta proton is shielded. That is also incorrect statement, because you know alpha beta unsaturation. Clear? And this is beta proton. Okay, first of all, it is the part of sp2 carbon, and also there is carbonyl group near to this double bond, and obviously this is electron withdrawing group, and obviously this proton is de-shielded, not shielded. So second statement is also incorrect. Clear? In the third statement, at 60 degree, the proton outside the 18 aniline is strongly de-shielded, and those inside are strongly shielded. This statement is correct. Clear? And you know the structure of 18 aniline. In that, there are different type of protons. One are outside and one are inside the ring. And outside the ring, protons are de-shielded, and inside are strongly shielded, but at 60 degree Celsius temperature. So third statement is correct. In the fourth statement, alpha pinene. Okay, they are talking about alpha pinene. Its structure is like this is its structure. There is double bond and one methyl group is here. So there are two germinal methyl groups. Okay, and they are saying one of the germinal methyl group is held in just such a shielded position, then its twin. The third methyl is de-shielded. Okay, so this statement is also incorrect actually. So one of the germinal methyl group is de-shielded, not shielded, and they are mentioning it as shielded. Okay, so both methyl groups are in different chemical environment. So fourth statement is also incorrect, and correct statement is third only. So third option is your correct answer in this question. In the last question, they are saying the following inner transfer reaction mechanism is slow if y is this y is. Okay, so inner transfer reaction mechanism. Okay, inner transfer reactions actually. So the correct answer, if you will take y as a chloride, okay, as compared to water, ammonia and hydroxyl group, in the case of chloride, this inner transfer reaction will be slow. Okay, so there are three reasons for that. First is strong field ligand. Second is ligand exchange kinetics. And third is steric hindrance. Okay, so first is strong field ligand. Okay, so you know that out of these four options, chloride is weak field ligand, not a strong field ligand. Okay, so it means that it doesn't, if it is weak field ligand, it doesn't create a large splitting energy in the crystal field. So if it is not going to create large splitting energy in the crystal field, which mean it can result in less efficient electron transfer. So reaction will be slow in that case also, okay, due to its weak field nature. Second is ligand exchange kinetics. So chloride can form relatively strong bond, okay, with the metal ions, so making ligand exchange reactions slower. So this slow down the electron transfer process, as it requires the exchange of chloride between the coordination sphere of metal ions in inner sphere reactions in maximum cases, not in this reaction. Okay, so ultimately ligand exchange kinetics also play a role. Okay, so chloride makes strong interactions with metal ions, so that's why your inner transfer reaction will be slow if Y is chloride. And last option is steric hindrance. Clear? So you know that chloride are relatively small and can pack closely around the metal ion, so potentially creating a steric hindrance that further slows down the electron transfer process. So these three options are playing role for slowing down the process of inner transfer reaction, okay, mechanism. So the remaining questions I will try to cover in next videos, and if you like the video, share it further and subscribe the channel. Thank you very much.